Okay, good morning everybody. It is Monday morning. That's 3/8 and hopefully my red group is taking their test. All the retakes are done. So anyway, here are the notes. So first of all, what's our objective? We're going to be doing reflections of functions, okay? So there's a couple of things we want to look at. First, if you see this negative f of x, that's the same thing as a y. So anytime you reflect over the y, so you're going to reflect that y's become negative. So y and f of x, so this is a reflection over the x axis, okay? Because the y's are negative, right? This is, the x's become negative, so this one is a reflection over the y-axis because the x's become negative, so it flips over the y-axis. So this is a reflection over the y-axis, okay? This one, the absolute value, means that anything that's negative or below the x-axis has to flip up. So to have an absolute value, you reflect all negative y values up over the x-axis so that things become positive, okay? So let me show you. Let's do some examples of these so you guys can see it. So example 1, it says given f of x below, draw negative f of x, f of negative x, and the absolute value of x. So, alright, so first of all, let's take a look at negative f of x. We're just going to flip all of our values over the x-axis. So we're going to take and just really rotate this like this, okay? So how is it going to look? Well, this point right here, which is down at -2, would flip up here to +2. So I'm going to put it right there. This is on the axis, so it stays where it's at. This value here at 0, 2 becomes 0, -2. And that goes like that. And then you can see, hopefully, the reflection here. Okay, it looks like this, this, and this. Okay. One way to do it if you get really confused is you can just take points if you have to. That's the point at 2, -2, and then if you're going to flip it and make it just simply a 2, +2, so you're going to change the y's, okay? This one, if you're going to flip it over the x-axis, so this is going to be over the x-axis. This one's over the y-axis. Let me write that down. Over y-axis. This one's going to be over x-axis. So I'm going to do that, and I'm going to flip it over the x-axis. So this whole entire graph is going to flip like this. So this little piece here comes over there, and then it's going to go down like this. So this piece is over the x-axis. Hopefully you can see that. This piece here is just going to come down like this. And there it is, okay? And again, you can just take any point you want and just change the x values, okay? Make the x values negative. So this point right here would have been -2, okay? And then finally, absolute value. I'm going to take this function and this negative part. So let me go and highlight it. The negative parts are going to flip up. The negative parts are going to flip up. So anything down under the x-axis is a negative y value. So let's just flip up. So anything that's positive stays positive, like any absolute value. So my graph should look like this. Okay, and right here, instead of going negative on this little piece, it pops up. And then this is still positive, so the positive values stay positive. It's above the x-axis. But this little value here is where the y values become negative, so they have to pop up or fold up. Okay? And that is how the absolute value graph looks like. Everything that's negative folds up. Everything that's negative folds up becomes positive. Okay? All right, now let's talk about symmetry. Okay? Over the x-axis. Okay? To be symmetrical over the x-axis, that means that, let me give you an example. Oh, a parabola. Oh, that's not true. That's over the y-axis, over the x-axis. Let me think about an example. It would be over the x-axis. Oh, look, yes, a line y equals 3 would be over the x-axis. No, wait a minute. Hold on. Over the x-axis. Symmetrical with the x-axis. Well, let me see if I can draw a picture. A sideways parabola would be symmetrical with the x-axis. Okay, so let's have a x equals a y squared. It's not a function, but it's definitely symmetrical with the y-axis, okay? I'll find one. I'll think of one that is a function. Okay, over the y-axis. And this is if it's an even function, so that's just a regular parabola. If I had a regular parabola, let me draw these in color, sorry about that. Okay, I would have something that looks like this. An example of that would be a y equals an x squared. We call that an even function, so anything that is symmetrical over the y-axis, we call it an even function. You can also see that you have an even exponent. Here's another one. I'll show you another one. If I have a graph like this, we've seen one like this before. This could be a
please come to the office.
Y equals an x to the fourth, maybe minus, let's say an 8x squared. I don't know, maybe. Anyway, that's an example. It's got even exponents, but most importantly, it is symmetrical with the y-axis, which makes it an even function, okay? And that's important when you get into calculus, okay? Now, over the line y equals x. Give you an example of that one. So that's got to be over this line right here. So we're going to fold something over this line, okay? If it's symmetrical with that line, oh yeah, we could have this graph right here. Let me show you a graph. This would be like a graph, like, okay, that would be like a graph of, it's a y equals, say, a 5 minus x. That would be that line right there, possibly. And if you fold it over this line here, then that's symmetrical over the line y equals x, okay? So, over 180 degrees makes an odd function, so it's a rotation. Let me see if I drew you a picture. How about this function here? So if you took this graph and you spun it right at the origin, 180 degrees, right? It spins, can you see it like a pinwheel spins onto itself? That is a rotation for 100, that's over the origin, and that makes an odd function. So the equation of this could be a y cubed minus maybe an 8x. And again, I see odd exponents, but the biggest thing is it has to be symmetrical with the origin, or any odd function always has to rotate over the origin. Okay, 180 degrees. All right, example 2. Example 2, graph y equals 2x minus 4. We're going to reflect it over the line y equals x. All right, line y equals x is this line right here. All right. What am I going to do? Well, let's use two different colors. Let's put the original function in blue. Okay. Start at -4. 1, 2, 3, 4. And I'm going to go up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, okay? There it is. So one way you can reflect over the line y equals x is you make the x values negative and the y values negative, okay? Example. So this is the point at 0, 1, 2, 3, 4, -4. Its reflection would be a 0, +4. So I could put its reflection of 0, +4. Okay? Which puts it, oh, you got to switch them too. Ah, dang it, I'm wrong. It is Monday morning. You got to make it a yx. My bad. I was doing a different reflection, sorry. I was doing that one. Okay, so switch them. So to have its inverse, change that to a -4, 0, 1, 2, 3, 4. Okay, this point is at 1, -2. switch the points, and I'd have a -2, 1. Okay. This point is at 2, 0. Switch it. I'll have it as 0, 2, and you can kind of see the graph looks like this, okay? So if you fold it over that line, I don't know, you could fold the paper, but if you took this and folded it, kind of right like that, it's going to fold over the line y equals x and puts it here. We're going to talk about that tomorrow. That makes it its inverse, okay? All right, now, what's the equation? Well, the equation on this one's pretty easy. It's just simply going to be a y equals a slope of up 1 over 2 plus 2, okay? Now, if we had to solve this, and we did this last year, you switch x and y. So if you actually had to solve this to get this answer, the math part, is you change x's into y's, and you solve, okay? Because you switch x and y's. So if I had to solve this one, I would go plus 4 plus 4. I would divide by 2 everything, and I would get a 1/2 x plus 2 equals y, and that is the equation I got anyhow, okay? All right, now, example 3, last but not least. So, let's graph y equals x minus 2 squared plus 3. Okay, I can graph that. It's a parabola. I'm going to do that one in blue. So I'm going to go a vertex at 2, 3, right? And I know it's got to be a parabola. It's got to look like this. Okay. Now, the reason we're going to look at graphing it by symmetry is because you can't put this in a calculator, okay? Desmos won't take it because it's not a function. But if I reflect it, because remember I switch x and y, that's all I did is I switched x and y, so I'm going to graph it over the line y equals x, okay? So I'm going to switch x and y coordinates. So this coordinate here, this one here is at 2, 3. So I'm going to switch it and make it a 3, 2. Okay. I'm off my line. This point here is at the point, let's see, 1, 2, 3, 1, 2, 3, 4, 4, 1, 2, 3, 4, 4, 4. So switching that is easy. I'm going to have a 4, 4 on that one too. So 4, 4 here. 4, 4. 1, 2, 3. Oh, it's 3, 4. Golly. 3, 4, which is a 4, 3. All right, that makes more sense. It's right there. I am making all sorts of mistakes. Let's get one more point. I think I'll be done. Let's take this point here, which is the point at 1, 4. I'll make it a 4, 1. There it is. And if I graph this, there's that equation. Okay? I went through kind of quickly because I'm not sure how the retake is going, but here it is. I'll load this up, and this will be available for you. Okay? So, there you have it.